Many disciplines, including philosophy, mathematics, economics, neuroscience, cognitive psychology, computer engineering, control theory, and linguistics, have contributed ideas, viewpoints, and techniques to the field of AI. We will only look at one of them, neuroscience. Neuroscience is one of those fields that has contributed many things to the field of AI. And neuroscience is basically the study of the nervous system, particularly our brain. Since 1929, the invention of EEG, electroencephalograph, has allowed us to measure the intact brain activity. That is, how does the brain function when it's at rest? However, with the recent development of something known as functional fMRI, functional magnetic resonance imaging, now we can unprecedentedly record or even check detailed brain activities while the brain is doing things. In other words, while EEG would allow us to check the activities of our brain at rest, fMRI allows us to look at the ongoing cognitive processes in our brain during activity. And these are further augmented. So this was our older technique, and now we can do something much more powerful than just watching brain at rest. And with recent techniques of single cell recording of neural activity, we can monitor individual cells, individual neurons, by stimulating them electrically, chemically, or even optically. In other words, what we can do is, if this is our brain, we can mark a single cell in our brain, one cell, by either putting some electricity in it, or by putting some chemicals into the cell, and then observing whether this particular cell fires or not, or this particular cell does something specific or is involved in a particular action or not. So these two techniques, particularly fMRI and single cell recording, provide us a lot of tools to understand how the brain works, and use that in the field of AI. Despite all of these interesting progresses, we are still a long way from understanding how cognitive process work. That is, how do brains cause mind is still a mystery despite all of these things that we can do. Let us look at how the functional magnetic resonance imaging, or the fMRI technology, works. The problem of how do brains cause minds can be summarized by this kid's rhyme. You may have heard the Humpty Dumpty rhyme. Humpty Dumpty sat on a wall, Humpty Dumpty had a great fall. All the king's horses and all the king's men couldn't put Humpty together again. That's what we are currently at in terms of understanding the brain and the mind. We can put our brain apart, look into all individual pieces. We know how a single neuron works, and we know the details of the brain. But what we can't do is we can't put everything together to understand how all of this together functions as a mind. Let us compare a supercomputer, a personal computer, and the human brain in terms of various things like computational units, storage units, cycle time, etc. What we find is, of course, we can't directly compare how things are stored in a supercomputer and a human brain, because brain stores information in neurons, whereas we have RAM and transistors to save information. In terms of cycle time, our human brain is much slower, 10 to the power minus 3, compared to what the personal computers and supercomputers can do. Our brain can also process slightly more operations per second compared to a supercomputer, and the memory updates is similar to a supercomputer. So, despite having a smaller cycle time than a computer, human brain is much more capable, and the brain makes up for that. There is a smaller or lesser cycle time by looking at by through these synapses. That is, a brain has way more interconnections between the neurons than what we can build in artificial neurons. So even with a computer that has a virtually unlimited capacity, we still wouldn't know how to achieve the brain's level of intelligence with transistors and storage that we currently have.